This part, chapter 6, is really more on bone physiology, some structure, but a lot more about bone physiology than actually what the bones are, femur, humerus, scapula, what have you. Okay, so first of all, skeleton has some cartilage in it. It assists in the skeleton. So this diagram is spots where cartilage is. Your nose. Now, the blue, if you look down, cartilage is red. So we can see on this guy standing there, your nose, that part of the nose that sticks off the front of your face, that's hyaline cartilage. It's not bone. Bone is way up close to your eyes. There's a little bit of bone that sticks out, and you can kind of feel, if you palpate that, you can kind of feel where the bone is and then where hyaline cartilage carries on. But that's the hard part of your bone, the hyaline cartilage, and then obviously bone itself. Other places you have hyaline cartilage, the hook to your ribs. Okay? Other places, hyaline cartilage provides a smooth surface for joints, the ends of long bones for joints. So in your elbow joint, your carpal, your femur. You can't quite see it on your knee because the way the guy is sitting. You can see it in the feet. So all those places, the ends of long bones that participate in a joint has some hyaline cartilage. It's labeled articular cartilage because of its position and its job at that point. And then if we look at elastic cartilage, your ear, you can bend your ear and it goes back, right? I mean, easily enough. If it was not elastic cartilage, it was hyaline cartilage, your ear would have broken and you would have these thingies that kind of flapped off of your head because it would have broken by just living through childhood. And then the last is fibrocartilage, which is very strong cartilage. So your intervertebral disc, meniscus in your knees. Those are fibrocartilage. The type of cartilage in any of these places really has to do with its functionality. Okay, so it helps. Okay, hyaline cartilage being the most abundant. So I talked about the articular cartilage, the coastal cartilages. Didn't say anything about respiratory cartilages, but I did talk about the nasal cartilage for the external nose. Respiratory cartilage, you have your trachea has C-shaped rings of hyaline cartilage. They are there to keep the trachea open. Next semester when we tie, you have to keep your trachea open. In and out of your lungs, okay, so they're very, very important. Osteocartilage, I already talked about the external ear, your epiglottis, and that flap that covers your trachea so that when you drink something or you swallow something, it doesn't go down into your lungs. Fibrocartilage, again, talked about where it's at. It is able to stand great tensile strength. So places where pressure and stretch is needed. Vertebral discs. As the discs, you move down your vertebrae, each one has to withstand your upper body weight. Your menisci, your knees, has to withstand virtually your whole body weight. Very strong structures. Growth of cartilage. Cartilage grows kind of similar to bone. We have oppositional growth. In other words, it grows on the outside surface of the cartilage, which is oppositional growth on the outside. So we have chondroblasts that just lay down new matrix in the existing cartilage, and it gets thicker. There's also interstitial growth, where chondrocytes can divide and lay down new matrix, so it grows from within, getting longer. Your coastal cartilages for your ribs, you weren't born, the ones that you were born with are bigger now, they're longer. Your chest is bigger. So we have to have a way of increasing not just the width of the cartilage, but the length of the cartilage. And so the interstitial growth is the length, oppositional growth is growing from the outside. Sorry. How do we classify bones? Bones are classified based on a couple things. First of all, First is, where are they? So, exoskeleton is shown in blue here. That's the part of the skeleton. For this next exam, you will be learning markings on bones, exoskeleton markings. They protect your internal organs. Then the appendicular skeleton is, I'm going to be sneezing again in a second. Sorry. I start talking and I sneeze and I cough. I really don't understand why. But anyway, that's life. Now, that's position. Where are they located? Versus appendicular skeleton. You can't live without your axial skeleton, that part of your body. You can live without your arms and legs. Maybe not real comfortable living, but there are people that's living without their arms and legs. Sorry. We look at shape of bones. Bones are classified based on shape. So we have long bones. They're longer than they're wide. So your humerus, which is pulled out there, is a long bone. And there's a lot of examples of long bones. Your radius, your ulna, which is your lower arm, tibia and fibula, which is lower leg, your metacarpals and metatarsals, the bones in your hand that, not your fingers, actually those two, but the bones in your hand are all long bones. So the palm of your hand, long bones. Your fingers, they're also long bones. Now, the littlest bone, like in your little finger, the very end, it's almost not longer than it is. Short bones, the opposite of long bones. They're about the same, width and length. Okay? So, short bones, your carpal bones, the bones that make up your wrist. Your tarsal bones make up your ankle. Okay? This book classified sesamoid bones as being part of short bones. Some textbooks will pull out sesamoid bones as a separate category. So what's sesamoid bones? They're bones that develop in places of need. Okay, so a good example is your patella or your kneecap. Virtually everybody has a kneecap, although some people that are born without kneecaps, and they live perfectly fine without the kneecap. But it is a bone that grows in a tendon. You'll sometimes get extra sesamoid bones, the sole of your foot, growing from, people will get it in their hands too. Okay. Another strange short bone is a sutural or wormian bone. Your skull, when your skull ossified or closed in, you know how a baby's born with a soft spot, one or two soft spots on his head. Well, those eventually fill in with bone. And sometimes as it's filling in, there's another little bit of bone that jumps in and starts growing in the middle of that open line. It still seals with the rest of the skull, but it's another little teeny bit of bone. So it's called a sutural or wormian bone, and it's in the skull. Again, perfectly normal. It's not something weird. It's just most people don't have it, but some people do. The next type of bone. So we've had long, short bones, and now we have flat bones. Flat bones, they're not all perfectly flat like a tabletop, but the way they grow is in a flat bone, or where they develop is in a flat bone. Sternum is a flat bone. When you look at your cranium, part that holds your brains, your frontal, parietal, temporal, and occipital lobes, they grow as flat bones. They're not flat because they're curved, but the development of them is in a flat bone development. Okay, your mandible, your ribs, the scapula, the pelvis, those are all bones that are classified as flat bones, and it really has to do with how they grow. They're more flat than they are long or short. Okay. And then we have irregular bones. What's irregular bones? Well, what's pulled out here is a lumbar vertebrae. It is an irregular bone. So your vertebrae, your sacrum, your coccygeal, all part of your vertebral column. Your middle ear bones, malleus, incus, and stapes, teeny tiny bones. The hyoid bone in your neck. And then some of your skull bones are irregular. They don't fit the other classifications. of bones. What does your skeleton do? Well, first of all, we know it hooks your limbs on your body, okay? Your lower limbs, your arms and your legs, actually is there for muscles to hook to so that you can move. Very much protection. Your soft organs. Think of your chest. Your ribs help protect your heart and your lungs. Your skull, very good protection for your brain. Your vertebral column, not as tightly encased in bone, but it's a very good protection for your spinal cord. Another thing, mineral and growth factor storage. Our bones have a lot of calcium and phosphate in it, and that's a storage place. If your body needs calcium or phosphate, then your bones are attacked. So if you don't eat enough calcium, then your bones become softer because they've been eaten up. Also, there's growth factor storage. So this insulin-like growth factors and transforming growth factors, so different growth factors are actually kind of stored in your bones. It is a place for hematopoiesis, which is blood cell formation. Now, bones don't form cells, blood, but it provides cavity for hematopoiesis to occur. You get older, your long bones that when you were a child was all filled with red hematopoietic tissue, those tend to turn into storage areas for fat. So they fill with fat. So it's a triglyceride fat storage. And then there's some hormone production. So osteocalcin helps regulate insulin secretion, glucose homeostasis, and energy expenditure from that hormone. And that's from your bones. This chart and the next one shows different markings. Stand when you say trochanter. What's a trochanter? Well, you look it down. It's a very large, blunt, irregular shaped process, and we only have it on the femur. But other things like tuberosity, it's the spot where muscles attach. A lot of these, the markings on bones is more than just, there's a femur showed here. There is a pelvis. There is a thoracic vertebrae shown. Yes, you need to know the names of the bones individually, but you need to learn a lot of the markings. You're not learning all of the markings. Trust me, there's a whole lot more. But you're learning some of them. And unfortunately, you don't have a lab to learn these in. You learn them as part of this class. I will point out that anybody that wants to have their hands on an actual skeleton, it's a plastic skeleton, get a hold of me and I will into the A&P labs. And this diagram also shows other markings for bones. And that's it for this little section. We will be back again shortly. Sorry.